Hello and welcome to the Department Day Chemistry presentation, everyone. I hope you guys are doing well and having a good day. So today we're going to be having Daniil Melnichenko with us here today to be the representative of the chemistry department. And he's going to be telling us about the department and why you should possibly choose that. A few things really quick before we start. So just so you know, the presentation is going to be about 45 minutes to 1 hour long at most, and we're going to have the actual presentation for about 30 minutes and then 15 minutes for Q&A at the end. And then for the actual questions that you guys want to send to us, you can send them on Slido, and I'll put that in the chat right here. There's the link and the code is right there, so feel free to send the questions there. We'll be answering those in the end of the presentation. And one more thing before we start, please change your name format. So the KAI students, you need to have your student ID and then your first name, and then people who are not from KAI, just your first name. All right, I'll put that in the chat as well. And yep, Daniil, the stage is yours.
Okay, hello everyone. Today I'm gonna present you chemistry department, and as Maida say, why you should choose it, but we will just discuss about our chemistry department. So in the front slide, I put the quotation from Sam Thompson saying, I guess chemistry is just now worth for love, because most people who choose chemistry are just like chemistry, just passionate about chemistry. So at first, quick words about a quick self-introduction about me. I am fall 2019 intake, so I'm now finishing my fall semester. I'm minoring in bio and brain engineering, and I'm from Kazakhstan, and my research interests are organic chemistry, surface chemistry, and biochemistry. And here is my Kakao Talk and Instagram. So if you have any questions, you can just ask me anytime. Okay, and one important note, I am, as most foreigners at KAIST, I'm a Hugi. I'm entered fall semester. That makes our studies a bit complicated, which we will discuss a bit later. So a little bit about department profile. Chemistry department is a part of the College of Natural Sciences, uniting physics department, mathematics department, and some graduate school of nanoscience. There are a total of 4 schools in our department, and we share the same building with biological sciences, E6, and so chemistry is E6-4, with, I think, some floors on E6-6, basic science building. Chemistry department is as old as KAIST itself, from 1971, and here you can find chemistry department website is chemkaist.kr. So there is a chart showing how many professors, students we have at the chemistry department, and it's about, I think this chart is quite old. I don't know the exact number for these days, but I think undergraduates are around 150, and maybe 20 of them are internationals. So, and if you're on campus, you've probably seen that chemistry department and as a whole School of Natural Sciences under renovation now. It was like this old 1980s building until now, and it's gonna be like brand new orange building soon, hopefully. Okay, so also a quick view about ratings. Recently published QS ranking for chemistry subject placed KAIST chemistry department at 24 amongst all top universities rankings, and you can see that it's going better from last years. Okay, and at first, as we're going to talk about department and your studies and specializations, we will talk about academics. So in order, I think all of you know that in KAIST you have to choose between advanced major, major and minor, double major, or individual design major. I'm doing major and minor. So, and for each of these categories, you have different requirements for graduation. Yeah. At first, let's discuss about advanced major. At first, you have complete all major required courses for all of the cases, which are listed here, and underline why I have taken, so you can ask me about them. And you also have to complete some number of major electives. I think this number is different for major, minor, double major, and individual design major and advanced major. In case you are doing advanced major, these two ones become major required for you. And also there are, if you do major, if you do double major, if you do major and minor or advanced major, you have to complete 9 basic electives. And general chemistry 2 is required for everyone who's majoring in chemistry, and general chemistry experiment 2 is required for those doing advanced major and major and minor. If you do double major, you don't need to take this. Okay, and almost all the classes are 3-credit classes, except these 2 major labs, and except this general chemistry experiment too. This one is 1 credit. These 2 are 2 credits. And also, if you want to graduate from the chemistry department and you are doing double major or major minor, you have to complete some research, which one is the graduation research. And you should also complete laboratory rotation program in and undergraduate curriculum. Also, you can do individual study, and we're going to talk about graduation research and individual study a bit later, because these are like very important stuff to talk about. Okay, so if you want, I can later describe some subjects of your particular interest later, but I think it will be better in Q&A session. Okay, so a quick view about facilities. We have a department room, which one is the X641140 room, and this room is available only for chemistry department students. And when you join department, they tell you the password for this room, so you can go there and study anytime. And it's pretty good to study there because it's open all the time. It's pretty quiet. There are a lot of books which you can borrow from there. Also, there are PC, and you can print as many pages as you can. And it's free, because if you print in dormitory cubes, it's gonna cost you something. Also, chemistry department has an NMR room, and this one is like very crucial if you do some organic or like organic related research, because you constantly need to go and do NMR. And any student can ask to do training at the NMR facility, and they will invite you. It will take maybe 4 or 5 hours, and you just do training, and then you can use NMR when you do your research. Also, maybe if you are already at KAIST, you know that we have KFTP website where you can obtain licenses for Adobe, Microsoft, and like MATLAB software. But for chemists, there is a very crucial software called ChemDraw. And ChemDraw is not available at KFTP. It's like separate procedure to obtain KAIST license for KFTP. And if you join chemistry department, you can contact chemistry department administration, and they will tell you how to obtain this one. Even you're a freshman now, you can already download it because it's quite useful, and it's, I think, available for all KAIST students, but you need to contact some KAIST professor, organic professor, or chemistry department administration. Okay, so, and when you go to any department, okay, if you're a freshman, you have like some academic advisor now, but this one just randomly chosen professor for you, and he doesn't or she doesn't like as a academic advisor yet. But like when you choose a department, you're gonna get an academic advisor of your interest within your department. And in case of some departments, I know that they're also randomly assigned, but in case of chemistry, when you choose chemistry department at the end of your freshman year, you will get an email from chemistry administration asking you to pick 3 professors of your interest and your fields of interest. If you have none, it's fine. And they're gonna choose a available professor for your advisory for like next 3 years, but actually you can change your advisors. It's not a big deal, but still. And how do you choose an academic advisor? Academic advisor is probably a professor whose lab you want to join in future. For example, I am now in lab of Chuan Song, Center for Cell Encapsulation Research, and he's my academic advisor. So I chose him because I wanted to join his lab in the future. Okay, and academic advisory is like, but it's not required for you to go to your academic advisor's lab. You can go to any other lab of your interest, because I think pretty all the labs in chemistry department are interesting. So about lab experience. Lab experience is very crucial for your future career, for your graduate school, and just for your skills. And I think at some point of time, every chemistry student joins a lab, any lab, and with any because either for graduation research or for some experience or for European stuff. And here we're going to talk about lab experience. If you remember, there were like individual study and graduation research. You do your graduation research probably in your 3rd or 4th year, and individual study, it's like a 1 credit course. You just go to lab and you get S or U, but I have no idea how can you get U for individual study. So you just go to lab, you are assigned with some graduate student or postdoc, and you do some research together, and they teach you how to do the research. It's just for your interest. But also you can do URP program. It's common for all Chi students, but in chemistry department and okay, no, it's common for all Chi students, and in specific departments, you can substitute your URP for graduation research. So you are not required to do graduation research in your fourth year if you do URP at the same time. And also the process of doing URP is that you are supervised from school. You need to submit your paper based on your a year research or 6 month research. And during this time you get scholarship. I think it's $1,000,000 for your time of your research, and also you get research funding. So it's like kind of real research. So so if you do URP in your fourth year, you can substitute it for your graduation research. So I'm about to start my URP now, but I cannot substitute it for the graduation research because I'm just entering my third year. And I did individual study prior to this, and gained some experience about what my lab is doing, how is the research do, how research proceeds and stuff. Okay, and now also if you want to do URP, I advise you to do individual study or just to go to a lab to get some knowledge about this. Okay, so and also if you want to join a lab, in my first semester, I also joined a chemistry lab. It was David Georgian's lab, and I didn't get any credits for it because I just asked professor. I mailed him asking if I can join his lab, and he said, okay, come, and we're gonna talk. And he just allowed me to join his lab, and I was just coming, studying, doing experiments and stuff. So you're not required to even register you for being in a lab. You can just come and study. Okay, about social life at our department. At first, we have a Facebook group, which you can find in Facebook. And as you join chemistry department or choose chemistry as your minor or second major, you will be added to Kakao group chat. Like in my case, it's for Hakwa 19 because I'm 19-year intake. And in this chat, they're gonna announce some events for chemistry department and stuff. So in chemistry department, there is a student council, but actually, I don't think most of international students can join it because you need to speak Korean to be able to join student council. But the student council itself organizes many events that foreign students can attend. For example, like Chem and Chem, like study room, study group, and what else? At some point, it's welcome party because even though it is in Korean, the student council does everything that they can to make it suitable for foreigners. They organize English speaking groups, English speaking professors to talk to you. So kind of foreigner friendly. And also at chemistry department, and I think many departments also do have it. We have a CA. I think it stands for counselor advisor, something like this. And CA is a graduate student who is assigned to you every semester and just comes to you, gives you coffee coupons, buys you smoothie, and you just talk about life and studies and just everything. So CA is just a graduate student from your department. And also before midterms and finals, we have study room. It's like Zoom meeting that you join and you can study with others. And we have study groups, so you can register a study group for your specific subjects with your friends, and you're gonna write reports. What did you study? And probably you're gonna receive some gift from the student council if you do a lot of research, do a lot of reports of your meetings. And Chem and Chem is it happens every semester. You just meet some other chemistry students and you just spend time together and that stuff. What else? So MC is only in Korean, so maybe not all of you can join if you join chemistry department. Okay, and also as any other department, chemistry department has jackets, which are pretty cool. Okay, so 1 second. Oh, Okay, and we're gonna talk about career path now because I think it is of the most of your interest when you choose a department. In the case of chemistry, and first thing you should understand, chemistry is a basic science. So chemistry is different from chemical engineering because in chemistry you study like fundamentals of chemistry, and in engineering, as it stands, you apply this knowledge. And chemistry is really good in understanding the subject because later in graduate school you can get a like you can study whatever you want. So you can go to engineering with more deep knowledge of chemistry. You can go to biology related studies. You can go to like anything the way chemistry can be applied, but chemistry can be applied in a lot of fields. And usually there is like two big branches where you can go after your graduate school is either academia or industries. So there are some specific examples of academia and industry I put here, but it's just general examples. I checked several research groups at our department and checked where its graduates went to. So in case of industry, they usually go to LG Chem, Samsung Electronics, Samsung Bio EPIs and stuff. And also there are some foreign pharmaceutical related companies, chemical industrial related companies as Pfizer, Sanofi and stuff. In case of academia, you can go to some university abroad to become a professor or become a like just researcher. It's not especially like it's not usually an university. You can go to some research center to do your research, but sometimes it takes time because in case of academia, you need to get a PhD, and probably it's gonna take a lot of time. But if you like it, as long as you enjoy it, time doesn't matter. It's my like vision of life. So okay. It's like general picture of everything that I wanted to tell you. So if you have any questions, I am more than happy to answer them. So there's something in the chat, right?
Yeah, so for the questions we have, so far we have two questions. So the first question is, you chose chemistry as a major and BBE as a minor. What, in your opinion, makes chemistry stand out more and be a major?
Uh, can you please repeat it?
So yeah, you've chosen chemistry as a major and like BBE as a minor. So what, in your opinion, makes chemistry stand out more as like the major and not as a minor? Or
Because
I
like
assume
as
this
I
was.
said, chemistry is just a basic science. It's like fundamental one. So at first I want to gain some deep knowledge of some natural science related stuff. And later I wanted to apply it to some bio-related fields in the future. And so for me to be easier in my future, I chose BIS, actually it's called as my minor to gain some experience in coding and like bioinformatics and stuff.
All right. And the next question we have is, what courses would you recommend for freshmen?
At first, okay. Also, I forgot to talk about how it is difficult if you are like fall intake, because in fall intake, there are like your schedule is a little bit different. It is a little bit harder to make your schedule because most of classes go in pairs. So for example, organic chemistry 1, organic chemistry 2, organic synthesis 1, organic synthesis 2, like biochemistry 1, biochemistry 2, physical chemistry 1, 2, 3. So they are all one start at spring. So if you're a freshman and you're fall intake, you are better to take in spring organic chemistry 1 at your second semester, organic chemistry 1 and physical chemistry 1 as like the basic subjects. And in case of physical chemistry, I think the order doesn't matter because physical chemistry 1 studies quantum chemistry, physical chemistry 2 studies thermodynamics, and physical chemistry 3 studies kinetics. But in case of organic chemistry 1, 2, and biochemistry 1, 2, like it just goes deeper. And the same with organic chemistry 1, organic chemistry 2, spring, fall. And in case of, but in case of labs, it's different. It's fall, spring, fall. So it doesn't, the order of taking subject doesn't matter as long as you can do with them, like, but still it makes things a little bit complicated if you are a fall intake. And in my case, I would recommend you if it depends on your prior knowledge before coming to KAIST. In my case, I studied chemistry a lot before coming to KAIST, so I took some advanced classes from like graduate available level, I think so. So such as Introduction to Chemical Biology or Organic Synthesis 1. But in case if you have no prior knowledge, I advise you taking Biochemistry 1, Bioorganic Chemistry. What else? Also, if you have some programming experience, there is like very interesting course class called Chemistry AI. I haven't taken this yet, but it's like very interesting, and I recommend you to take it. But it is if you have some experience in coding. Also, what else? I recommend you to take all the major required classes. All of them are interests. All of them are interesting, but I haven't taken physical chemistry 2 yet. So yeah. And in case of major labs, in case, even though there is a COVID, these labs are online now, or are offline now. So you have to be on campus if you want to attend them. That's why I couldn't attend major lab 1 because I was in my home country last semester. Yep. So probably all major required courses are pretty interesting. I recommend you to take them. And in case of basic knowledge from electives, I think Biochemistry 1, Bioorganic Chemistry, Physical Organic Chemistry, Biochemistry 2, like any subject. It depends on your interest because, chemistry is like very diverse field. Even though it's very fundamental, it's very diverse. So if you want to do more physics related stuff, it's like reaction dynamics, molecular spectroscopy. If it's like more biology or organics, you do biology or organics. And you need to put attention on course code. If it's 200 or 300, it will be easier than it is 400. But in my case, I think 400 and 500 classes are like, they're also kind of easy because they are for graduate students, and graduate students are mostly focused on their researches. So, and they don't put much attention on their classes. So it's not that hard to get a good grade for 4 and 500 codes.
Oh, right. So you can basically take 400 and 500 level courses being an undergraduate, no problem.
Yeah, I think 2, 3, 4 are they are all undergraduate level, but 4 and 5 are a bit easier to couple with because they're for like graduates and there is no much load for them. But in case of 2 and 3, they can be a great load, and it can be harder to get a good grade because there are a lot of students taking them. So, but they're like more basic knowledge.
Oh, okay, right. All right. The next question is also kind of related to this one. Can you describe the courses in more detail? Which are the harder ones? So I guess you've kind of already answered that, but if you want to add anything.
I think in case of physical chemistry 1 is like organic chemistry 1 is kind of like the most easiest one because most of foreigners coming to KAIST, they already have some experience in organic chemistry from their high school. But in case of physical chemistry 1 and physical chemistry 2, probably they're kind of the hardest one because there are a lot of calculations and usually people get not that high grades here, like maybe B+, A- stuff. And inorganic chemistry 1 is pretty generous course. I'm taking this now. And it's kind of interesting to do labs because you do experiments and there is no finals and midterms. You just write lab reports and you just midterm paper and final paper. So it's kind of easy. It's more interesting to take and it's kind of easy to couple with. And also I recommend you taking biochemistry too. It's like very interesting. I like the professor because he focused a lot on studying actual papers rather than studying the subject. Okay, no, we studied the subject, but also focusing on papers is very important if you want to go to academia in the future. So this class I very enjoyed, and I think I enjoyed most of the classes I have already taken.
Okay, all right. This is like my question. Have you taken computational chemistry yet, or are
No,
you interested in that? Okay.
I'm interested in it, but I haven't started doing yet. I'm planning in next semester, like shifting my interest to that.
All right, okay. The next question we have is, can one take physical chemistry 2 or organic chemistry 2 without taking part 1 of these courses?
Yeah, of course you can. And in case of physical chemistry too, it's totally fine because it's no way connected to like, okay, it is connected in some sense, but it's very easy to do thermodynamics without doing like quantum chemistry. But in case of organic chemistry 1 and 2, you can take organic chemistry 2 without doing organic chemistry 1 if you have some prior knowledge in organic chemistry. Because it's organic chemistry 1 is just like very general class about like chemistry reactions and stuff. It's kind of easy and fine to do the so. And also in chemistry department there are no prerequisites, so you can take any class you want as long as you feel like you able to couple with it. So but yeah, I think no comments.
Um, the next question we have is, what do you think differentiates chemistry from other subjects for you, such as physics, biology, maths, etc.?
Okay, so I have no idea how to answer this question because I joined chemistry in my 8th class of my middle school. So I feel like connected to chemistry a lot because I spent a lot of time with it. So, but still for me, chemistry uh, is more like synthetic stuff because it's just for me, but chemistry is very diverse. As I already said, it's already like biochemistry, physical chemistry, computational chemistry. But in my case, it was like organic chemistry, about synthetic stuff, about creating new substances, studying how they react with each other, because all of them is kind of application of like physical laws, because in a nutshell it's physics, but it can be applied in biological studies as like protein foldings, as like biochemical reactions and stuff. So for me, this shift from physics fundamentals to biological fundamentals was very interesting. It was the birthplace of chemistry. And in case of math, I don't know, math is just really different. Math is just math. It's like logics and stuff, and I have no idea can I distinguish chemistry from math. Math is more fundamental than chemistry. So
Yeah, that makes sense. I think that was a really good answer. Then we have another question. Can you tell us more about lab rotation?
lab rotation program. I think I haven't taken this class yet, but I know that it happens maybe every week or every second week. You just kind of get presented of every lab in the department. And you can also, as a freshman, you can take this class if you want to know more about chemistry labs. And they just tell you about each lab department, and I think lab is in fall and colloquium is in spring, so you can next fall, or maybe other way around, but you just can take this class to know a little bit about what every lab does in their researches. So
Oh, so you can just like drop this into your courses during course registration, or is it
yeah,
the
yeah,
same procedure that you said for?
yeah. This like individual study, undergraduate colloquium, laboratory rotation program, it is like classes. I think we can call them classes because all of them are 1 credit courses. You register them and you do something that is required from you. In case of individual study, you can do it whenever. You just go to lab, you talk to graduate students, you talk to postdocs and study, and professor then gives you like your grade based SOU, based on do if you did well during this individual study. But in case of lab rotation program and integrated colloquium, you just attend kind of lectures
Mhm.
and get presented.
Right. So this is like optional anyway, right? So if somebody were to be like double majoring, then they probably wouldn't have to take this, or
I'm
would
not
you
sure about
recommend they take?
double major. I'm not sure about double major. You need to check this one. But in case of major, minor, and advanced major, you are required to take these two. Um, if you join chemistry department, they're gonna send you some like list explaining what you need to take, when you need to take it, and how you need to register it and stuff.
Oh,
So,
okay.
or if you do minor in chemistry, you can just ask chemistry administration office for this kind of document to learn about what it can do. And also, this is public. I think KAI's bulletin KAI's something like this. You can find such a document there, but I think it's not that descriptive as chemistry department can give you.
All right. Okay, that's nice to know. The next question we have is, how active is the KAIST chemistry department on the theoretical aspect?
I have no idea what this question stands for. Uh,
Whoever
you know,
asked the question, can you give us some more details? You can put in the Zoom chatting if you want. What exactly do you mean? Like theory versus practical, perhaps?
I,
Like how
like
much emphasis is on the theory and how much emphasis on actual lab
when
work?
you take classes, you learn theory. When you go to lab, you do practice and you apply like your theoretical knowledge. And also you gain practice when joining these lab classes. And like um, I think most of major required courses and most of major, like all the major required classes and most of major elective classes are very theoretical based. So you just go and learn theory, read textbooks, read papers, read textbooks, solve problems and stuff. So you do a lot of theoretical study. And if you want to do more practical, you can do this one or Europe.
Right. Okay. The next question we have is to do a minor, does one need to take any of the major labs if you're doing a minor?
Let me check. If you do minor, I'm not sure about this one. I think in case of minor, you have to take all major required classes. And major labs are included, but I'm not sure. It was bulletin cast, right? Yeah. Natural sciences, chemistry. In case of minor, you have to take 21 credits from major classes. So you need to take 21. So you are allowed not to take one lab.
Okay, so you could like drop one lab, but you're supposed to take all of the theory courses.
You have to take this list is 24 credits. And if you want to do a minor, you need to do 21 credits. So you can like drop one. You cannot take major lab 3, for example, and it will be 22 credits. No, it will be 21 credits.
All right. Suppose could they like potentially drop physical chemistry?
Yeah, you can take others and don't take physical chemistry and still get a minor for this.
All right. Okay. Okay. So the next question is, what do you plan to do?
I'm sorry. I'm wrong. So you need to take 21 credits from chemistry department, like in general, and 20 must be here. 20 must be here. What 20? 12. 12 must be from here, and others can be from here. You need to take 21 in total, and 12 must be from here, and others must be from anywhere.
Okay, so in these 12, it doesn't matter whether you're taking labs or...
Physical chemistry 1, physical chemistry 2, organic chemistry 1, organic chemistry 2, that's all. So this will be 12 credits, and you can take some other classes to fill this 21 credits requirement.
Okay, all right. Yeah, so like the next question is, what do you plan to do after graduation?
This is kind of hard question, but at this point, I'm definitely going to graduate school, and later I will see. But at this point of my life, I'm thinking of going to academia because I'm very interested and very kind of passionate about doing research and stuff. But it may change in future. But at this point, I'm planning to go to academia. And
so would you like continue at KAIST, perhaps?
Not sure about this one. I still need to wait, because I'm second year student at this point and I don't know.
Yeah, there's a lot of time until then. All right, so the next question is, what are the job prospects for physical chemistry except academia, for physical chemistry in particular?
You'd better to ask some guy who's doing physical chemistry because I'm not doing physical chemistry, but I think there are like a lot of stuff related to electronics, because I have a friend who studies in Imperial College London, and she studies physical chemistry, and she is interested in to going into some battery related field. So battery production like is maybe some of industry prospect of studying physical chemistry. But at the same camps, it's as well as an analytical chemistry. Because in KAIST, the professor giving analytical chemistry is doing some battery related research, as far as I know. So, and maybe some, I'm not sure, you'd better to ask someone who is doing physical chemistry.
All right, okay. So that's all the questions we had so far, actually. If anyone has any more questions, please feel free to ask either on the Slido, or if you want to Zoom chat, it's fine too. There's not a lot of us here. So we'll give you guys a couple more minutes, and if you don't have any more questions, then that would be the end of the session. So does anyone have anything else to say? Any other question? Anything you're curious about? Please feel free to put it on there. Daniil, do you have anything to add in particular? Something about chemistry or some course or anything?
Like, in my opinion, if you go to chemistry department, like, I don't force you to go to chemistry department because it just, usually chemistry is for people who like chemistry, who want to learn it deeper. And if you go to chemistry department, I advise you to go to some lab to learn if you like to do this, and if you don't like to do this, just to check if it is yours, because most of chemistry, real life chemistry experiments is in the lab, regardless if it's academia or industry. So you had better to choose a lab at the department and go there to see, to experience it. And if you don't like it, you can just leave the lab and go to different lab, because every lab is different. They do different things. They work differently. So it's better to visit as many labs as you can if you can find the lab that fits your interests. So, but if you don't go to chemistry department, that's also fine.
All right. Someone is asking, who is your favorite professor in the chemistry department?
I can answer this because I like, so far all the major classes I took, and I'm taking now, I like all the professors because all of them are kind of kind. They're very interesting. Because if like, after freshman classes, you have some not a pleasant experience with professors, but in case of major classes, all the professors are very involved in the classes. They like do a lot for make the class being interesting for you. And so I don't know. Actually, I'm taking two classes. Like, for every class, you have a different professor. But in case of organic chemistry 2 and organic synthesis 1, I'm taking the same professor gives this class. So Hyung Kim professor. And I find he's been very, like, in case of organic chemistry, I like him explaining the topics. But actually, all the professors are good. Or inorganic chemistry, physical chemistry, analytical chemistry, biochemistry. I like all of them.
Yeah, I agree with that. I'm taking organic chemistry 1 right now. The professor is like, he's really engaging, super enthusiastic. Just tries to make the class amazing. Yeah, so the next question we have is some advice. So they're asking, for someone who's not sure whether to choose chemistry or not, what would be your advice to make that decision?
I think you can take some counseling service at KAIST and go there to see if you want to take chemistry or not. But if you're interested in studying something fundamental, not applications, you'd better to go to chemistry rather than some engineering field. But if you are interested in some applications, and if you are not very passionate about going to graduate school and spend more years at graduate school, you'd better to not to go to chemistry department, because I think most, like, if not all, most of chemistry students go to chemistry department or go to graduate school.
Oh, okay. So on that note, if somebody were to like go into industry, should they go through graduate school first, or can they go into industry like directly after undergraduate from KAIST?
I'm not sure about this one. Maybe they can, but I think going to graduate gonna like be much more better for them. It will be easier to get a job after doing graduate studies.
All right. The next question we have is, what subfield in chemistry intrigues you the most?
I like organic chemistry. I like, as I said, I like organic chemistry, surface chemistry, and biochemistry. And my research is kind of related to first two, especially the second one. So, kind of like this. I like exploring this stuff. And actually, I'm about to discover more of computational chemistry because it's like promising field. So probably if I like it, it's going to be one more of my research interests in the future. So,
All right.
any questions?
Yeah, sorry. Yeah, so this question is, what if confused between, I mean, the person's asking if they're confused between physics and chemistry.
Oh, I
Then
know this one is like really two different stuff. I have no idea how to choose between physics and chemistry. You need to talk to some like attend physics presentation, see
Yeah.
what they tell about physics department, and talk to some people from physics department. I don't know. Just you,
Yeah.
you can take some basic
Yes.
classes from both departments and see which one you like, because and there are some classes, I think they're called special topics in something. So each department has special topics in chemistry, special topics in biology, special topics in physics, and you can take these classes, see what it is like, and just choose. But I don't think if you choose between physics and chemistry, there will be a wrong decision, because either is fine. In my case, I was choosing between biology and chemistry. Like I was doing biology as my second major, but then I changed it to bio brain as my minor, because I wanted to do something more computational, something more applicable than just simply learning biology, because I'm doing fundamentals in chemistry and I'm doing applications in my brain, stuff like this. But in case of physics and chemistry, I have no idea, because they both are kind of fundamental natural sciences.
So, like in your opinion, we can't really pick between the two. Like they're both equally important in their own
Probably, yeah,
aspect.
probably equally fine.
All right. Okay. The next question is from the person who asked about the theoretical aspect of the chemistry department. They're asking if you could possibly repeat what you said because their connection was lost at the time.
Uh,
So if you could just
I,
summarize real.
I said that just if you do classes, they are theoretical. You just read textbooks, solve problems and stuff. But if you want to gain experience, you go to lab and do lab experience for like some practical skills. And also, I know then it was offline classes, intro to analytical chemistry, did a huge emphasis on doing like experiments in class, but now due to online study, it is purely theoretical. And these major lab 1, major lab 2, major lab 3 are purely practical classes. But most of classes are theoretical based, so you just go and learn theory.
All right, thank you. That's all the questions we have for now. Once again, if anybody has any other questions, please feel free to drop them in. We technically have 7 more minutes of the presentation time, so you guys can ask anything. And also do note that these presentations will be uploaded on the Kisa YouTube channel eventually. So we'll let you know when that happens, and like watch the space, keep an eye on the YouTube channel. The presentations will be there in case you missed something, you can catch up. And if you have like general queries about majoring and minoring and credits and stuff, then I've put the link to the drive in the chat where you can find these things. We will also be uploading Daniil's presentation, like the PDF of the slides, so you guys can have access to that if you're interested. And yeah, we still don't really have any questions. So yeah, we'll wait a couple more minutes again. Okay, we've got another question. So this person is asking, what do theoretical chemists do assuming they exist?
Oh,
That's a bold.
no, actually, we have like, I know one guy who's doing theoretical chemistry studies. It's theoretical chemistry is small. In my view, it's mostly about computational chemistry, because you study how reactions react, you like you assume some general trends, you try to overview some, you propose some synthesis based on, I have no idea how to describe it. They just do a lot of computations. I think it is Professor Bake's lab in English, and his labs does a lot of computations. And also I know that my lab does some computations, but I'm not on this part. But I think you'd better to take some class from Professor Bake about this, because, and also introduction to molecular spectroscopy maybe, because these professors are into some theoretical field a little bit. But I think mostly theoretical chemistry means computational chemistry, for me at least.
Right. Okay. Thank you for that. All right, so someone is, I think they're asking about this, that is it more like simulation work?
Kinda,
Theoretical chemistry?
kinda. It's more like
Hmm.
calculations. And
Okay.
also molecular dynamics. I think physical chemistry 3. No, the department head, his lab is about dynamics, chemical dynamics. So uh, he doesn't give any classes, but his lab is about chemical dynamics, and this is also, I think, theoretical chemistry.
Right. Okay, we have another question. What's your favorite lab chemical?
Huh?
Your favorite
Um,
lab chemical? What's your favorite chemical in the lab?
I
I
don't
guess
know.
what's your favorite chemical to work with, I guess?
I have no idea. I don't like working with chemicals because most of them are toxic. I don't know. But there are many jokes with me between my friends about dichloromethane. I don't
Uh,
know. Just often joke about this. But,
like chloroform?
but yeah, no, not chloroform, dichloromethane, CL. Yeah,
Dichloroform. So, mm-hmm.
I
Okay.
like that. Okay.
Mm-hmm. Yeah, again, we don't have any more questions. So I guess we'll.
Also about chemistry, I know that many guys who were doing chemistry in the past, maybe 2000s, they went to some petroleum related fields, especially because these guys were from Kazakhstan, and Kazakhstan was like emerging field for like petroleum related stuff. So most of chemists in my past in 2000s went to petroleum related companies and gas related companies. So maybe this is also one of job prospect for you.
Right. We have another question. Do you ever have conflicting opinions on established theories in chemistry?
Um, like nowadays, some like it happens a lot because nowadays there are a lot of theories being proposed in chemistry, but later they can come up being wrong. For example, it happens in biochemistry when you talk about metabolic processes because it may just you just try to discover some pathway, but it ends up this pathway is not right after some time. And same can be happening in organic chemistry when you talk about some reaction mechanisms because you suggest some one reaction mechanism, but later it's gonna be very different. Um, Probably there are some such like controversies in quantum chemistry as far as I know, but I'm not really into them. And what else? Um, I think probably because sometimes you cannot clearly identify some very fast processes like reaction mechanisms. You There are some controversy about them because some people use one approach to discover the process, and other people use another approach to discover the process, and they end up having different results. So they try to speculate on them and get different theories. But at the end of the day, only one of them will be right.
Right. That's a good answer, I think. Another person is wondering, what do analytic chemists do in general?
Analytical chemistry is about uh, analytical chemistry is more about studying qualitative. It's like qualitative analysis or quantitative analysis. It's like real analysis. So at first, there are some traditional methods, as you can maybe heard of, such as titrations and stuff, to identify the composition of some materials. And another method is like spectroscopy. If you take intro to analytical chemistry, maybe first half of the semester will be about some traditional approaches like titrations and stuff, like equilibrium solutions and stuff. But second part of the semester will be about molecular spectroscopy, such as FTIR, mass spectroscopy, fluorescence-based spectroscopy, and stuff. So they usually learn at first the composition of some materials. They learn how can we discover these compositions, like using these molecular spectroscopy techniques. And yeah, probably like this. And then sometimes I often see that analytical chemists are very connected to electrochemists. So that electrochemistry is like basis for batteries, like energy and stuff, energy storage and stuff. So usually they're more into that field.
Right. So there's an overlap between physical chemistry with analytical chemistry.
Yeah. Overlaps between chemical fields are everywhere because if you do organics, there are a lot of physics and physical and analytical chemistry. If you do analytical, it also you do with maybe with proteins sometimes, and it's biochemistry. And in case of organic chemistry, and in case of physical chemistry, you may study organic materials and some overlaps with analytical in terms of tools and stuff. So like there are overlaps everywhere.
Oh, all right. The next question that we have is any internship opportunities one should look out for during undergrad?
In my case, I haven't done any internships yet because at first I spent 1 year back home, so I couldn't do anything really. And now I'm like, one of internships is CRP. I would call it an internship because you do research in lab and you get paid for it. But in case of general internships, there are like many companies in Korea, especially where you can do some practice. It's better to check KAIST global internship center, something like this for about this. And also you can contact some pharmaceutical companies, some chemical companies if they have internship opportunities. However, sometimes I think that some of them may be difficult for you to get because they will want you to maybe be somewhat fluent in Korean, but still I think it's doable. And of course, yeah, there are less opportunities and less internship possibilities in comparison to computer science, but still there are a lot of them. And if you want to get one, you will get one.
I'm assuming the final question for today is are all chemistry theories just empirical?
What do you mean by empirical? I don't think so. Can you please like explain why you think so?
Yeah, whoever asked this question, please do elaborate a little bit more on it if you're still here. Like, what do you mean by that?
Most of chemical theories, I wouldn't call them empirical because in case of, if you take, for example, physical chemistry one, they will explain you all this stuff. It's not like you do measurements and you find out this being that, so you do correlations. Sometimes it does happen, but often it does not like this because you study why does it happen. Because answer it is working is like for mainly usually for engineers, so they do something, they see it is working, so okay, they are fine with it. But for case of scientists, for case of like lab, like academic chemists, they just do something, it is working, and then they ask why. So we study why something is working and we try to understand why it is working. And in this case we are doing some specific methodics depending on your field to discover why is it happening. For example, in case of biochemistry, it can be radionuclide labeling. In case of organic chemistry, it can be the same. It can be some spectroscopy tools. Actually, spectroscopy is one of the fields that is emerged in order to help us understand the nature behind chemical processes and stuff like this. If you want to know how this spectroscopy and stuff work, I advise you to take this class, Introduction to Molecular Spectroscopy by Park Kyung Kusunim. She delivers it very clearly, and you get to understand how why like what like quantum processes are responsible for spectroscopy tools and stuff. So I wouldn't call it empirical, but sometimes, yeah, we apply on empirical theories until they are proved without like without some with some fundamental stuff.
Mhm. All right, thank you. Yeah, I think that's about it. We haven't had any more questions,
Thank
and
you all for these interesting questions.
yeah, those were some really interesting questions. I think we can end the session here then. Daniel, do you
Okay.
think? Yeah.
Yep. I think so.
So thank you everyone once again for coming. I'm gonna stop recording soon, but before that, I just want to remind you guys, for those of you who are still here, you can check out the general information in the link in the chat, and these recordings will be uploaded on YouTube on the Kisa channel. So yeah, look out for them. Thank you so much for coming.